Okay, so today we will learn about the topic of which is oxides of nitrogen. So we will learn today in this topic we will learn about the structure, the properties of the oxides of nitrogen, and then we will also learn the environmental significance. So we will cover these three topics for the oxides of nitrogen. Regarding the structure of the oxides of nitrogen, first we should know that there are about six types of the oxides of nitrogen. So these are the main types of the oxides, which include the nitric oxide, nitrous oxide, nitrogen dioxide, dinitrogen trioxide, dinitrogen tetroxide, and dinitrogen pentoxide. So these are the resonance structures here I have given for each of these nitric oxides. So these are the types of resonance structures that are possible for these oxides, and with their shape, the geometry. So they are linear. The first one, which is a nitrous oxide, it's linear. The nitric oxide is also linear. The next, which is dinitrogen trioxide. So it's a planar molecule with three different bond angles, and the nitrogen dioxide is angular, so it has kind of bent shape. Here you can see here it's a bent shape, and the next one is the dinitrogen tetroxide. So you have all these atoms in laying in a plane, and it's a planar molecule, and it has two different bond lengths. So due to the resonance, the bond lengths between the nitrogen and oxygen on both sides is same. And if you go to the next one, the last one is the dinitrogen pentoxide. So it's also a planar molecule with some bend at the middle, which is the oxygen connecting the two NO2 groups. So this is all about the structure of the nitric oxides. So the next is we are going to study their. So let's first talk about the nitrous oxide. So the nitrous oxide is it's colorless and is very less reactive. So it's a neutral oxide, so and is slightly soluble in the water. And about the magnetic properties, so it's diamagnetic in nature, and this is also called as laughing gas. So this is sometimes when you inhale it, you will feel a sensation of laughing sensation. So that's why it's called as a laughing gas, and it decomposes on heating. So when you heat this to a certain temperature, at high temperature, it decomposes to its constituent elements. So it also reacts with sodium amide. So when it reacts with the sodium amide, it is gives the sodium azide and ammonia and sodium hydroxide. So it's kind of showing the reactivity with sodium amide. It also plays a very important role in the oxidation of sulfur, magnesium, phosphorus, and carbon. So when you want to the oxides of these elements and the pass the nitrous oxide gas, these elements are converted into the respective oxides. Sulfur is converted to sulfur dioxide, magnesium is magnesium oxide, so is the phosphorus and the carbon. And in the presence of heated copper, so when the copper is hot and you pass the nitrous oxide gas, you will get copper is oxidized while the nitrous oxide is reduced to nitrogen gas. The next one is the nitric oxide. So the nitric oxide is a slightly poisonous gas and is also colorless gas. So it's insoluble in water, but and it's neutral. So this is very important to know about the nitric oxide, and it's paramagnetic in nature. So this is if you see the molecular orbital theory, you will find the reason for the nitric oxide to be the paramagnetic to show the paramagnetic behavior. Reacts with the oxygen, so it gives the nitrogen dioxide, and that is a brown color. You will see the brown fumes when you expose it to the oxygen, and that brown fumes confirm the formation of nitrogen dioxide. And it's a very it acts as a reducing agent, so it decolorizes the potassium permanganate, which is purple here, and that this manganese is reduced to from +7 to +2 oxidation state, and that makes this manganese that decolorize this potassium permanganate while it is purple before reacting with the nitric oxide, and but this happens in presence of the acid, while the nitric oxide is oxidized to nitrate ion. So it is thermodynamically unstable. So with the once you heat it, it again it is decomposed to its constituent elements, and on reacting with copper, it shows again the copper is oxidized here, and while the nitric oxide is reduced to the nitrogen gas, and it forms the uh, complex with the transition elements. So if you see that if you want to do the Brown ring test for the confirm for the presence of nitrates, so you can see that this forms a complex which is the Brown complex in presence of ferrous sulfate and sulfuric acid. So it forms this complex which is brown color, and once this brown color complex which is a nitrosonium complex, and that helps us to indicate the presence of nitrates. So this is called also called as the Brown ring test for the nitrates. The next one is the dinitrogen trioxide. So it is also called as the nitrogen cis oxide. So this is the another name of this oxide of nitrogen, and it's deep blue that you can see. It's deep blue in color, and it's a solid, and it can also be a liquid depending on the temperature. This is an acidic compound, so it's also a low boiling point. So and it's highly combustible, so that means it can be used as a fuel, and it helps in the combustion of many substances like wood, paper, oil, clothing. And coming to it is the magnetic properties. It's paramagnetic in nature, so it has means unpaired electrons that makes it paramagnetic. It is soluble in water, and it reacts with the reducing agents. For example, with hydrogen, it's reduced to the nitrogen, and while hydrogen is oxidized and it gave hydrogen, it's changed into the water. When this dinitrogen trioxide is mixed with the water, reacts with water to give the nitrous acid. So it is a kind of it is the anhydride of nitrous acid. Nitric dinitrogen trioxide can be called as the anhydride of nitrous acid, and when you heat it, it also decomposes to the other oxides of nitrogen. So the next one is the nitrogen dioxide. It's a very common oxide of nitrogen. It's reddish brown. It's a very bad, irritating smell. And so if you smell it, you will feel very bad, and it has got a acidic taste. So it is acidic in nature, and it's paramagnetic. So that is also a magnetic property of this behavior of this oxide. Tells us it is paramagnetic in nature. So it reacts with water to give the nitrous acid and nitric acid. And if this you react this nitrous acid further, you oxidize. So in excess oxygen, this nitrous acid can be converted into the nitric acid. So it acts is shows the equilibrium with the nitrogen dioxide. So and that's a temperature dependent, and at low temperature you will see it acts as the dinitrogen tetroxide, but when the temperature is increased, that it changes into the nitrogen dioxide, and it decomposes on heating as well. It reacts with the alkali, so for example, potassium hydroxide and sodium hydroxide to give the salts of the potassium nitrate and sodium nitrate. So it reacts with the alkalis as well. And it helps in the oxidation of the magnesium and phosphorus. So magnesium and phosphorus burn more brightly in presence of the nitrogen dioxide, and to give the corresponding oxides of magnesium and phosphorus. It also reacts with copper, and again the copper here it is oxidized like the other oxides, and the nitrogen dioxide is reduced to the nitrogen gas. So the another one is the nitrogen tetroxide. So it's simple, very similar to the nitrogen dioxide, and it's colorless at the lower temperature. But once you heat it, it changes into the nitrogen dioxide, and the color changes into the brown. That brown color indicates the formation of nitrogen dioxide. So it is a temperature dependent equilibrium with the nitrogen tetroxide and nitrogen dioxide. So it's a powerful oxidizing agent, and it's diamagnetic in nature. It you know, when you react it with the water, you get nitrous acid and nitric acid as well. So it helps in the nitration of the organic compounds. And the last one is the nitrogen pentoxide. So nitrogen pentoxide is a colorless solid, but you can sublime it directly at above the room temperature. So you can convert it directly to the gas, and it's solid below room temperature. It's a solid compound in the form of NO2 and NO3 ion, but it's unstable in this form, and in the gas phase it is covalent in nature. So it's diamagnetic in nature, and it's a strong oxidizing and nitrating agent. So we can use it in the organic synthesis. So it oxidizes the iodine here. You can see, and to the iodine oxide. It's soluble in water. So when you react it with water, you get the nitric acid, and with the sodium hydroxide, it gives sodium nitrate and water. So this is all about the properties of these. And now finally we can see the environmental significance. And environmental significance, we know that volatile organic compounds react with the nitrogen dioxides to give the peroxide style nitrates, which are also called as PA and PAN. So this is the formula of the peroxide style nitrate. And these volatile organic compounds in presence of oxygen and light form this radical, and that radical reacts with the nitrogen dioxide to form the peroxide style nitrate. So these they are very harmful pollutants. The pan is and they are found in the photochemical smog. So this when you see this nitrogen dioxide, which is present, which is formed in different ways in the atmosphere, then it reacts with water and further oxidized to give the nitric acid. So that nitric acid goes above in the clouds, and then it falls back as heavy droplets that we call as the acid rain. So we have this nitrogen dioxide is the helps in the catalysis of oxidation of the sulfur dioxide. So once it reacts with sulfur dioxide, that it converts sulfur dioxide into the sulfur trioxide, and that sulfur trioxide when it comes in contact with the water, it forms the sulfuric acid, which is also dangerous for the materials for the buildings. So this is all about the environmental significance of these nitrogen dioxides. So hope you enjoy the lecture. Thank you.